Okay, so again, remember that there is no talking while we're doing notes here. So this first one, what you're going to do is the first step is exactly the same. You're going to write an x here, right? You're going to write an x here. The difference is, and the major difference, is that now there is a number in front of x squared. Okay, so the big difference for these types of problems, these are the hardest types of problems, Justin, is that there is a number in front of x squared. Brandon? Yes. So the first thing we're going to do up here is that instead of just writing 3, we're going to do a times c, which is a is the number in front of x squared, and c is the number, a constant. So 2 times 3, which is equal to 6. So the difference here is that instead of just writing c, because there is a number in front of x squared, we're going to multiply the number in front of x squared, and we're going to multiply c. Okay, the only difference is that on top it is no longer just c, it is a times c. And actually before it was a times c, we just didn't do so. Or we did, it was just 1 times that number. That's why it was just the number itself. The number on the bottom is 5. So you actually want to do the same thing here. You want to think about what two numbers when multiplied equals the top number while being added together equals the bottom number. What numbers can we think about here? 3 times 2, so we have 3 and 2. I will say that for this method there are 2 different ways. The first method I'm going to show you is the way that I prefer because it's more easily reproduced. Abdul, please stop talking. If you need to move, I will move you. As your first and final warning. Secondly, what we're going to do is now we're going to draw a box. This is what we call the box method. Okay, so this is where the differences really start to come in. So this is the method I call the X box method. We can't actually group this. If you want, you could start grouping, but I will show you that after this method. The first thing is that in this box on the top left, you're just going to write this first part. So 2x squared, you could just throw in there. And then on the bottom right, you're going to throw in the c value, or 3. Okay? So again, this value right here is going to go in the top left of the box, and this 3 is going to go in the bottom right. Okay, so those two numbers that you came up with, the 3 and the 2, we're going to stick them in. It doesn't matter, it could be here or the other one. I'm going to write 2x and 3x. So this 2 is going to be 2x, and this 3 is going to be 3x. If you're wondering where those numbers come from, I'm going to show you after this method, through the grouping series, I'm going to show you where these numbers come from. Okay, so just like biology, if you guys remember Punnett squares of mixing genotypes, we're going to think about what number, what times what equals this on the bottom. So what times what equals this number on the bottom? Austin? 2x and x. You said x squared and maybe 2. Okay, so that's a possibility. So if we had 2x and x squared, could we also, let's just say, for example, we had x squared on top. Could we multiply something times x squared to equal 3x? So just like the Punnett square, you're not only going to equal this one, we're also going to have something on the outside, which is also going to equal 3x. Okay. So what you can see here is that if you have x squared on one side, it's really not going to work because we're going to have, we just need one x on one of these sides. Mariana?
So I think when it was above 2x squared, it would be just x, and to the left of 2x squared, it would be 2x.
Okay, so you're correct, and we'll talk about why in a bit. Something I want to note is that we're actually going to have an x on top, and we're going to have an x on the left. Okay, Olivia? So we're going to have an x on top, and we're going to have an x to the left. So this is interesting because we want to see what two numbers, when multiplied, equals 3, but at the same time, x times a number is equal to 3x. Does that make sense? We want to make sure that there's a number on the bottom here that when multiplied with this equals 3x, and then a number here, which multiplied with a number here, will equal 2x. Austin?
It would be, it would be 3 in the bottom left and 1 in the top right.
That is correct. So that would be positive 3 down here. It would be positive 1 right here. So you're probably wondering, well, x times x doesn't equal 2x squared. So what we need to do to fix this is what Mariana said, is we're going to write 2x here. So let's check our work. So what we want to see is x times 2x equals 2x squared. And then 2x times 1, does that equal 2x? It does. We have x times 3, which equals 3x. And we have 3 times 1, which is equal to 3. So you can see here that all of these boxes, they multiply to equal what's inside the boxes. So what's on the outside of the boxes, when they're multiplied, so like 2x times x equals 2x squared. 2x times 1 is equal to 2x. X times 3 is equal to 3x. And 3 times 1 is equal to 3. So then, what we would write our answer as, we're going to take this over here. This would be 2x plus 3 times x plus 1, which is right here. And that would be our answer. So what you've just done is you've successfully factored out where a is greater than 1. Okay, so this is method number 1. And we'll do a couple more today just to practice. Okay. So I'm going to show you the second way. The second way is that you can, after this step, we can go ahead and go back to this step. So, if you remember, I'm just going to go ahead and say we factored it out again. We did a times c, which is 2 times 3, which is equal to 6 on top. Okay. Does anyone still need the first problem, by the way? We'll do a couple more today just to practice this. Again, your test is now moved to Wednesday. Sorry about that delay. So on the bottom, this is the same problem. So it's exactly the same problem. This is just method number 2. This is method number 2. So you can see here that we came up with the numbers 3 and 2. And what I want to show you is that actually in our original equation, we have 2x squared plus 5x plus 3. This can be converted into 2x squared plus 2x plus 3x plus 3. If you're wondering where I got this 2x and 3x from, if I combine these, they become 5x. These two numbers that I actually got from right here. Right? I got the 2 and the 3. This is the 2x and the 3x. You can see that I actually specifically ordered this correctly so that I could group these together. This method is called grouping, which we've done before. And so now, if you guys remember, what we can do is we can factor out the greatest common factor. So these two, I'm going to factor out 2x. This becomes x plus 1. These two, I'm going to factor out 3. It becomes x plus 1. And then I'm going to combine this, so this becomes 2x plus 3 times x plus 1. So you can see here that these are two different methods where I can factor out something where a is greater than 1. So if you're thinking to yourself, what is going on here? Well, again, what we're doing is we're building on our previous work, and now we're using our grouping after we're using our factoring, and we're using what we call the Xbox method to arrange numbers so that we know what times what equals the inside.